Okay, in this question, we're asked to use the washer method to find the volume of the solid generated by revolving the region bounded by these curves, y equals x squared plus 1 and y equals x plus 3 about the x-axis. Alright, the way to approach these kinds of questions is first of all draw a picture to get an idea of what's actually occurring. So, let's suppose that we draw our first one, which is a parabola, like this, which is y equals x squared plus 1. Right, the other one is x plus 3 is a line, so 1, 2, 3 has a slope of 1, so let's suppose we go through here like this, and so we've got 2 points of intersection, and this will be y equals x plus 3. So this region here is the region that we are revolving around the x-axis. Okay. Now the first thing we would like to know is where do these two functions intersect each other? Well, they intersect each other when x squared plus 1 equals x plus 3. So this will be when x squared minus x minus 2 equals 0, or when when we factor this, of course, we get a 2, a negative 2 and a plus 1, and we have x is equal to negative 1 and 2. So this means this is 2 and this is negative 1. Right, now why are we using the washer method? Well, the reason is that this region is going around the x-axis. Okay, so we're producing this three-dimensional object, okay, around the x-axis. Now, if I was to do just the area underneath the x plus 3 function, then I would have this like a disc with this slope of 1 on the sides here going all the way around. So if I was to do it just around the underneath the parabola, then I would get this other strange ended disc, alright, around the x-axis. So since we have an area in between the two, if I look at the width of a washer that would be produced by taking away from the disc produced by the x squared plus 1 rotation and the area, alright, that produces the volume due to the x squared plus 1, then we're looking at this here being the width of the washer as it's being rotated. And so consequently we would find the volume would be the integral from negative 1 to 2 of pi. Alright, now if we look at the areas of the discs, okay, and these discs will be in fact dx wide, so that's why we're going to get a volume. This is where our third dimension comes in. But if we look at the two dimensions, alright, if I come across here, A of the outer one, area of the outer one, which is under the x, the x plus 3, alright, would be in fact pi, and let's call the outer one r of x. That's squared, that's the radius, and this one here would be the x plus 3 function. The inner area would be pi of this disc here would be r of x squared, which is the inner one. So we need to take those two away, so it'll be r of x squared minus little r of x squared dx. Right, so let's put in the functions now. The volume then would be negative 1 to 2 of pi by x plus 3 squared, that's the outer radius, minus x squared plus 1 squared, the inner radius, dx. So this will be the integral that I need to evaluate to obtain the volume of the solid using the washer method. So I'm going to pull the pi out. It's the integral from 1 to 2 of x squared plus 6x plus 9 minus x to the 4 plus 2x squared plus 1 dx. Alright, so have a look at this integral. This is just these ones expanded out. So this will be pi integral -1 to 2. And let's collect some things together here. So we're going to have a negative x to the 4, that's by itself there. We're going to have an x squared minus a 2x squared, so give me a negative x squared. We're going to have a 6x, and we're going to have 9 subtract 1, which is 8 dx. Right, so this will be the integral that we need to evaluate. Alright, so let's do that. Alright, so here's our volume. It's going to be negative x to the 4 minus x squared plus 6x plus 8 dx. This is the integral that we need to be able to find. Okay, so this will be pi. Now we can apply the power rule for integration for each of these because this is a polynomial. So this will be negative x to the 5 on 5 minus x to the 3 on 3 plus 6x squared on 2 plus 8x, and we need to evaluate that between -1 and 2. Alright, so this becomes, using the fundamental theorem of calculus, will be negative 32 on 5 subtract 2 cubed is 8 on 3. Okay, so this will be a 3 here, so it's going to be plus 3 by 4, which will be 12, plus 16. Okay, subtract. When I put a -1 in here, this will become -1 to the 5 is -1, and a negative will become a 1/5. Okay, this one will be negative, so this becomes 1/3, positive 1/3, and this of course will become let's see, 3 by that, so it's going to be plus 3, and subtract 8. Alright. Okay, so this becomes pi. Let's have a look here now. So it's going to be negative 32 on 5 subtract 8/3 plus, what do we got here, 28. We're going to subtract a 5th, subtract a 3rd, and of course we're going to have 3 subtract 5 is, 3 subtract 8 is -5, so it becomes plus 5. Alright, so it's just arithmetic now. So we end up, okay, so we get to working out the arithmetic here, and we end up with pi by, okay, so if we add all of this up, and you may want to use a calculator to do that, you will end up with let's end up with 351 on 15. Okay, and do we end up being able to do this by 3s? Well, maybe. So I end up with 117 on 5, and so my volume is equal to 117 pi on 5 units cubed.